May 1, 1960, Soviet airspace, 70,000 feet above Sverdlovsk. Francis Gary Powers is flying a U-2 spy plane, photographing Soviet military installations. The U-2 was supposed to be untouchable. It flew higher than any Soviet fighter could reach, higher than any missile could climb. But at 8:53 a.m., a Soviet SA-2 missile detonates behind Powers' aircraft. The blast tears off the tail. The U-2 tumbles from the sky. Powers ejects. He's captured within hours. 2 weeks later, the Soviets parade him on television. They display the wreckage. They show the cameras, the film, the evidence. President Eisenhower is humiliated, the CIA is exposed, and the United States has lost its eyes in the sky. The CIA needs a replacement, not just another spy plane, something the Soviets can never touch, something so fast, so high, that missiles can't reach it and fighters can't catch it. They go to Kelly Johnson at Lockheed's Skunk Works. Johnson has 18 months and an impossible mandate: build an aircraft that can fly at Mach 3 at 85,000 feet over the Soviet Union and come home untouched. Johnson builds the SR-71 Blackbird. It becomes the fastest air-breathing manned aircraft ever built. It flies so high, the pilots wear spacesuits. It flies so fast, its defense is to accelerate. When a missile launches, the pilot doesn't evade. He pushes the throttles forward and outruns it. The Soviets fire over 4,000 missiles at the Blackbird during its operational life. Not one ever hits. This is the story of the gorgeous beast that ended the Cold War. To understand the SR-71, you need to understand the problem it was built to solve. In the 1950s, the United States had a problem. The Soviet Union was a closed society. No journalists, no tourists, no satellite imagery yet. The CIA had no idea how many bombers, how many missiles, how many nuclear weapons the Soviets had. So, in 1956, the CIA commissioned Lockheed to build the U-2, a high-altitude reconnaissance aircraft that could fly at 70,000 feet, above Soviet fighters and missiles, and photograph military installations. For 4 years, it worked. U-2s flew over the Soviet Union with impunity. The Soviets knew they were there. They tracked them on radar, but they couldn't reach them. Their fighters topped out at 50,000 feet. Their missiles couldn't climb high enough, but the Soviets kept working on it. They developed the SA-2 surface-to-air missile, longer range, higher altitude, and on May 1, 1960, they finally got one. Gary Powers was flying a U-2 over Sverdlovsk when the SA-2 detonated behind him. The blast didn't hit the aircraft directly. It didn't have to. The shock wave was enough. The tail section tore off. The U-2 went into an uncontrollable spin. Powers ejected at 15,000 feet. He was captured by Soviet farmers and handed over to the KGB. The Soviets had been waiting for this moment. They put Powers on trial. They displayed the wreckage at a public exhibition in Moscow. They invited foreign journalists. They showed the cameras, the high-resolution film, the evidence of American espionage. President Eisenhower had to admit it. The United States had been flying spy planes over the Soviet Union. The summit with Khrushchev collapsed. The Cold War got colder, and the CIA lost its eyes in the sky. But here's the thing. Even before Powers was shot down, the CIA knew the U-2's days were numbered. Soviet missile technology was improving. It was only a matter of time before they could reach 70,000 feet. So, in 1958, 2 years before the shootdown, the CIA had already started a secret program. Codename Oxcart. The goal: build a successor to the U-2, an aircraft that could fly higher and faster than any missile. They went to Clarence Kelly Johnson at Lockheed's Skunk Works. Kelly Johnson was a legend. He had designed the P-38 Lightning in World War II. He had designed the F-104 starfighter, the first aircraft to hold simultaneous speed and altitude records. He ran the Skunk Works, Lockheed's secret advanced development division, where engineers worked on projects so classified they couldn't tell their families what they were building. The CIA gave Johnson the specs. The aircraft had to cruise at Mach 3.2. It had to fly at 85,000 feet. It had to have a range of 4,000 miles. It had to be invisible to radar, and it had to be operational by 1963. Johnson looked at the requirements and said, "We can do it, but it's going to be expensive, and it's going to require materials and techniques that don't exist yet." The CIA said, "How much?" Johnson said, $22 million per aircraft. In 1958 dollars. That's about $230 million today, the most expensive aircraft ever built at the time. The CIA said, "Build it." Johnson and his team started with the basics. To fly at Mach 3, you need to solve three problems: heat, drag, and fuel. At Mach 3, air friction heats the aircraft's skin to over 500 degrees Fahrenheit. Aluminum melts at 660 degrees. So aluminum was out. Steel was too heavy. Titanium was the only option. But titanium was rare, expensive, and almost impossible to work with. It required entirely new manufacturing techniques. And here's the problem. In 1958, the Soviet Union controlled most of the world's titanium supply. So the CIA had to set up shell companies to buy titanium from the Soviets without them knowing it was going into an American spy plane designed to fly over their territory. The Soviets were, unknowingly, supplying the material for the aircraft that would spy on them. Next problem: drag. At Mach 3, every surface, every rivet, every imperfection creates drag. Drag creates heat. Heat creates structural failure. So Johnson designed the SR-71 with a shape that minimized drag. Long, sleek, with Chinese along the fuselage that generated lift and reduced radar cross-section. No right angles, no flat surfaces. Everything curved, everything smooth. The result looked like something from science fiction. A black dart with a needle nose and twin engines. It didn't look like an aircraft. It looked like a missile with a cockpit. Third problem: fuel. At Mach 3, conventional jet fuel would ignite from the heat, so the Skunk Works developed a new fuel, JP7. It had a flash point so high you could drop a lit match into it and the match would go out. It wouldn't ignite unless you added a chemical igniter, triethylborane, which ignited on contact with air. But JP7 created another problem. At Mach 3, the fuel tanks heated up. The fuel expanded. If the tanks were sealed, they would rupture. So Johnson designed the tanks to leak. On the ground, the SR-71's fuel tanks weren't sealed. Fuel dripped out of the seams. The aircraft left a trail of JP7 on the runway. Only when the aircraft reached Mach 3 and the titanium skin heated up and expanded would the tanks seal. It was insane. An aircraft that leaked fuel on the ground and only became airtight at Mach 3. But it worked. The first test flight of the A-12, the predecessor to the SR-71, took place on April 26, 1962. It was piloted by Lockheed test pilot Lou Schalk. The aircraft reached Mach 1.1 on its first flight. Within a year, it was flying at Mach 3.2. The CIA had its spy plane, and the Soviets had no idea it existed. The SR-71 Blackbird became operational in 1966. Its mission: fly over hostile territory, photograph military installations, and return home untouched. And for 32 years, that's exactly what it did. The SR-71 flew missions over the Soviet Union, North Vietnam, China, North Korea, the Middle East, and Cuba. It photographed missile sites, airfields, naval bases, and troop movements. It provided intelligence that shaped U.S. military strategy for 3 decades. And the Soviets tried everything to stop it. Let me walk you through what it was like to fly an SR-71 mission over Soviet airspace. You start at a U.S. Air Base, Beale Air Force Base in California, or Kadena Air Base in Okinawa. You suit up in a full-pressure suit, the same kind astronauts wear, because at 85,000 feet, if the cockpit depressurizes, you have about 15 seconds of consciousness before you black out. The pressure suit keeps you alive. You walk out to the aircraft. It's sitting on the runway, dripping fuel. The ground crew has already pre-flighted it. The JP-7 fuel tanks are full, but they're leaking. Fuel is pooling under the wings. It's normal. The aircraft isn't designed to hold fuel on the ground. You climb the ladder into the cockpit. The cockpit is cramped. There's barely room to move. The instrument panel is analog. Dials, gauges, switches. No computers, no fly-by-wire. Everything is mechanical. You strap in. The ground crew seals the canopy. You start the engines. But here's the thing. The engines won't start on their own. JP-7 won't ignite without a chemical starter. So the ground crew injects triethylborane into the engines. It ignites on contact with air. The engines roar to life. You taxi to the runway. You're still leaking fuel. You take off. The aircraft is heavy. It takes the entire runway to get airborne. You climb to 26,000 feet. And then you do something no other aircraft does. You refuel. The SR-71 can't take off with full fuel tanks. It's too heavy. So you take off with partial fuel, climb to altitude, and meet a KC-135 tanker. You plug into the tanker's boom and take on 80,000 pounds of JP-7. Now you're ready. You light the afterburners. The engines scream. You accelerate. Mach 1, Mach 2, Mach 3. The aircraft is shaking. The noise is deafening. And then, at Mach 3.2, everything smooths out. The shaking stops. The ride becomes glass smooth. You're flying faster than a rifle bullet. You're at 85,000 feet now. You look out the window. The sky is black, not blue, black. You can see the curvature of the Earth. You can see stars in the daytime. You're at the edge of space. You cross into Soviet airspace. Soviet radar picks you up immediately. They know you're there. They scramble fighters. MiG-25 Foxbats, the fastest interceptors in the Soviet arsenal. They can reach Mach 2.8. But you're flying at Mach 3.2. They can't catch you. The Soviets launch surface-to-air missiles, SA-2s, SA-5s, the most advanced missiles they have. You see the launches on your radar warning receiver. The missiles are climbing toward you. They're fast, but you're faster. The pilot's response is simple. He doesn't evade. He doesn't turn. He pushes the throttles forward. The afterburners kick in. You accelerate. Mach 3.3. The missiles can't keep up. They run out of fuel and fall back to Earth. The Soviets fire again and again. Over the course of the SR-71's operational life, the Soviets fire over 4,000 missiles at Blackbirds. Not one ever hits, because the SR-71's defense isn't evasion, it's speed. If you can't catch it, you can't kill it. You complete your photo run. The cameras in the nose and belly of the aircraft are capturing high-resolution images of Soviet missile sites, airfields, submarine pens. You turn for home. You're still at Mach 3.2. You cross back out of Soviet airspace. The fighters give up. The missiles stop launching. You descend. You slow down. You refuel again from a tanker. And then you land. The entire mission took 6 hours. You flew 3,000 miles into hostile territory and back. And the Soviets never touched you. The SR-71 pilots had a saying, "Speed is life." And they were right. But the Soviets didn't give up. They kept trying to find a way to stop the Blackbird. They developed the MiG-31, a faster interceptor. They developed the SA-10 and SA-12 missiles with longer range and higher altitude. They tried to predict the SR-71's flight path and position missiles ahead of it. None of it worked. The SR-71 was simply too fast, too high, and too unpredictable. It could change course mid-flight, it could accelerate out of a missile's engagement envelope, and it had electronic countermeasures that jammed Soviet radar. The Soviets called it the Black Ghost, and they never caught it. The SR-71 wasn't just fast, it was an engineering marvel. Every system, every component, every detail was designed to operate at the edge of what was physically possible. Let me show you how it worked. Start with the engines. The SR-71 was powered by two Pratt & Whitney J58 turbojet engines, but calling them turbojets is misleading. At Mach 3, they operated more like ramjets. Here's how it worked. At low speeds, the J58 functioned as a normal turbojet. Air entered the inlet, was compressed by the compressor, mixed with fuel, ignited, and expelled out the back. Standard jet engine operation. But at Mach 3, the airflow into the engine was moving faster than the speed of sound. Supersonic airflow is unstable. It creates shock waves. Shock waves cause the engine to stall, so the SR-71 had movable inlet cones. As the aircraft accelerated, the cones moved forward and back, positioning themselves to create a series of shock waves that slowed the incoming air to subsonic speeds before it reached the compressor. This was called the inlet spike. At Mach 3.2, the inlet spike was doing most of the work. It was compressing the air so efficiently that the turbojet compressor was almost unnecessary. The engine was operating as a ramjet, with the inlet spike acting as the compression mechanism. And here's the crazy part. At Mach 3.2, 80% of the SR-71's thrust came from the inlet spike and the afterburner. Only 20% came from the turbojet itself. The engine was barely running. The aircraft was being pushed forward by compressed air and burning fuel in the afterburner. It was brilliant, and it was the only way to sustain Mach 3 flight. Next, the fuel system. The SR-71 carried 80,000 pounds of JP-7 fuel. That fuel wasn't just for propulsion, it was also the coolant. At Mach 3, the aircraft's skin heated to over 500 degrees Fahrenheit. The nose reached 950 degrees. That heat would destroy avionics, hydraulic systems, and the pilot. So the fuel was circulated through the aircraft before being burned. It absorbed the heat, cooling the systems, and then was fed into the engines and burned. The fuel was the coolant, the hydraulic fluid, and the propellant. It was a closed-loop system. Nothing was wasted. But here's the problem. At 500 degrees, the fuel tanks expanded. The titanium skin expanded. The entire aircraft grew by 6 inches in length at Mach 3. The engineers had to design every joint, every seam, every panel to accommodate that expansion. And remember, the fuel tanks leaked on the ground. They only sealed when the aircraft reached Mach 3 and the titanium expanded. That meant every SR-71 mission started with a fuel leak. The ground crew would watch JP-7 drip onto the runway, and that was normal. It was insane. But it worked. Next, the cockpit. The SR-71 had a crew of 2, a pilot in the front seat and a reconnaissance systems officer, or RSO, in the back seat. The RSO operated the cameras, the sensors, and the defensive systems. The cockpit was analog. No computers, no digital displays. Just dials, gauges, and switches. The pilots navigated using a sextant, the same instrument sailors used in the 18th century. At 85,000 feet, you could see stars in the daytime, so the sextant worked. The pilots wore full-pressure suits. The suits were connected to the aircraft's environmental system. If the cockpit depressurized, the suit would inflate and keep the pilot alive. But the suit was uncomfortable. It was hot. It was restrictive. Pilots said it felt like wearing a medieval suit of armor. And if you needed to use the bathroom during a 6-hour mission, you didn't. You wore a diaper. The pilots also wore special gloves. The cockpit controls were metal. At Mach 3, the cockpit interior heated up. If you touched a metal switch with a bare hand, you'd get burned. So the gloves were insulated. Every detail was designed for survival at Mach 3. Next, the cameras. The SR-71 carried several camera systems. The primary system was the TEOC, the Technical Objective Camera. It could photograph a license plate from 85,000 feet. The resolution was classified, but pilots said it could read a newspaper headline from 16 miles up. The cameras used film, not digital sensors. Film, rolls of film, thousands of feet long, loaded into the aircraft before the mission. After the mission, the film was developed and analyzed by CIA and Air Force intelligence officers. The SR-71 also carried electronic sensors, radar warning receivers, signals intelligence systems, infrared sensors. It could detect Soviet radar installations, missile sites, and communications networks. It was a flying intelligence platform, and it was all analog. No computers, no digital processing. Everything was mechanical, optical, and chemical. It's hard to believe now, in an age of satellites and drones and digital imaging. But in the 1960s, 70s, and 80s, the SR-71 was the most advanced intelligence-gathering platform in the world, and it was all built by hand. Every SR-71 was custom-built by Lockheed Skunk Works engineers. No two aircraft were exactly alike. The tolerances were so tight, the materials so exotic, that mass production was impossible. Lockheed built 32 SR-71s. 13 were lost in accidents. None were ever lost to enemy action. The SR-71 was retired in 1998. The official reason was cost. Each flight hour cost $85,000. The Air Force said satellites could do the job cheaper, but the real reason was simpler. The SR-71 had done its job. The Cold War was over. The Soviet Union had collapsed. There was no longer a need for a Mach 3 spy plane. The last SR-71 flight took place on October 9, 1999. The aircraft flew from Los Angeles to Washington, D.C. in 64 minutes. It set a coast-to-coast speed record that still stands today. And then it was parked at the Smithsonian National Air and Space Museum, where it sits today. The fastest air-breathing manned aircraft ever built, a titanium masterpiece, the gorgeous beast. The SR-71 was an engineering marvel, but it was nothing without the pilots who flew it. Only a select few were chosen to fly the Blackbird. The Air Force looked for pilots with thousands of hours of flight time, experience in high-performance aircraft, and the temperament to handle a machine that operated at the edge of human capability. One of the most famous SR-71 pilots was Brian Schul. Schul was an Air Force fighter pilot who had been shot down over Cambodia in 1972. He suffered burns over 40% of his body. Doctors said he'd never fly again, but Schul recovered. He returned to flight status, and in 1986 he was selected to fly the SR-71. Schul later wrote a book about his experiences, Sled Driver. In it, he described what it was like to fly at Mach 3. He wrote, "At Mach 3, you're not flying an aircraft. You're managing a controlled explosion. The engines are screaming, the fuel is burning at 3,000 degrees, the airframe is flexing and expanding, and you're sitting in a cockpit at the edge of space, watching the Earth curve below you." Schul also told a story that became legendary among SR-71 pilots. He was flying a mission over Libya. A Navy F-18 pilot radioed air traffic control and asked for a speed check. The controller said, "You're at 620 knots. The F-18 pilot sounded pleased. Then an F-15 pilot radioed in and asked for a speed check. The controller said, "You're at 1,350 knots. The F-15 pilot sounded smug. Then Schul, flying the SR-71, keyed his radio and asked, "Center, Aspen 20, can you give us a ground speed check?" There was a pause. Then the controller said, "Aspen 20, I show you at 1,842 knots across the ground." Schul said, "Roger that. We're showing a bit more up here." The F-18 and F-15 pilots went silent, because at Mach 3, the SR-71 wasn't just faster than other aircraft, it was in a different category. It was untouchable. But flying the SR-71 wasn't just about speed, it was about precision. At Mach 3, you're covering a mile every 2 seconds. If you miss your photo target by 1 second, you've missed it by half a mile. So the pilots had to fly with absolute precision. They had to hit their marks within seconds, within feet, and they had to do it while wearing a pressure suit in a cramped cockpit at 85,000 feet, with Soviet missiles launching at them. It was the most demanding flying in the world, and the pilots loved it. Another famous SR-71 pilot was Richard Graham. Graham flew over 100 SR-71 missions. He later wrote a book, SR-71 Revealed, in which he described the camaraderie among SR-71 pilots. He wrote, "We were a small community. Only about 80 pilots ever flew the SR-71. We all knew each other. We all trusted each other. Because when you're flying at Mach 3 over hostile territory, the only people who understand what you're going through are the other SR-71 pilots." Graham also described the moment when the SR-71 was retired. He said, "It felt like losing a friend." The SR-71 wasn't just an aircraft, it was a living thing. It had a personality. It demanded respect. And when it was gone, there was a hole in the sky. The SR-71 pilots were a unique breed. They flew higher and faster than anyone else. They operated at the edge of space. And they did it with a level of skill and professionalism that defined the Cold War. The SR-71 didn't fire a single shot during its operational life. It didn't drop a single bomb. It didn't engage a single enemy aircraft. But it helped end the Cold War. Here's how. During the Cold War, both the United States and the Soviet Union were locked in an arms race. Each side was building more missiles, more bombers, more nuclear weapons, and each side was terrified that the other side was building more. This was called the missile gap. In the late 1950s, the U.S. feared the Soviets had more ICBMs. In the 1960s, the Soviets feared the U.S. had more. The fear drove both sides to build more weapons, but fear is based on uncertainty. If you don't know how many missiles the other side has, you assume the worst. You build more to compensate, and the arms race spirals out of control. The SR-71 ended that uncertainty. By flying over Soviet territory and photographing missile sites, submarine bases, and bomber fields, the SR-71 gave the U.S. an accurate count of Soviet military capabilities. The CIA could see exactly how many ICBMs the Soviets had, how many bombers, how many submarines, and the numbers were lower than the U.S. had feared. The Soviets weren't building as many missiles as the U.S. thought. They were struggling economically. Their military was large, but it was inefficient. The SR-71 photos proved it. This intelligence allowed U.S. policymakers to negotiate arms control treaties with confidence. They knew what the Soviets had. They could verify compliance. They could trust, but verify. The SALT I Treaty in 1972, the SALT II Treaty in 1979, the INF Treaty in 1987. All of these treaties were possible because the U.S. had accurate intelligence on Soviet capabilities, and much of that intelligence came from the SR-71. The SR-71 also provided intelligence during crises. During the Yom Kippur War in 1973, SR-71s flew over the Middle East and photographed Egyptian and Syrian troop movements. During the Soviet invasion of Afghanistan in 1979, SR-71s monitored Soviet military activity. During the Iran-Iraq War in the 1980s, SR-71s tracked missile launches and chemical weapons use. The SR-71 was the eyes of U.S. intelligence. It saw everything, and it was never caught. But by the 1990s, the world had changed. The Soviet Union collapsed in 1991. The Cold War was over, and the SR-71's mission was complete. The Air Force retired the SR-71 in 1998. The official reason was cost, but the real reason was simpler. There was no longer a need for a Mach 3 spy plane. Satellites could provide the same intelligence at a fraction of the cost. But here's the thing. Even today, more than 25 years after its retirement, the SR-71 holds records that have never been broken. It's still the fastest air-breathing manned aircraft ever built. It still holds the coast-to-coast speed record. It still holds the altitude record for a non-rocket-powered aircraft. And it was never shot down, not once. In 32 years of operational service over hostile territory, with thousands of missiles fired at it, the SR-71 was never touched. Kelly Johnson and the Skunk Works built an aircraft that was 50 years ahead of its time. And even today, there's nothing like it. The SR-71 Blackbird, the gorgeous beast that ended the Cold War.